Okay, before writing anything down, you probably need to look, sorry about that, at the visual of what I'm going to show you. For each problem, find the area of the region enclosed by the curves. So let me show you this. So since 2 root x is a little bit smaller than 3 root x, that's this function right here. Well, the area under that curve from 0 to 4 is here, the yellow, and then the 3 root x, the area under that curve from 0 to 4 is all of that. So notice the only part that they care about is this part. Well, it's the 3 root x subtract the 2 root x. And remember, the area under curve is an integral. So what we care about is that blue area. And here's our lower bound and our upper bound. So this is, you write the area is equal to the integration symbol from 0 to 4 in parentheses. The upper graph right here is 3 root x. This graph is 2 root x. And it's this entire area subtract this area. Well, that area is this. So it's 3 root x subtract 2 root x dx. Well, since they both have the same radical, 3 subtract 2 is 1. So area equals square root of x, or since you know it's a radical, you can use this notation. And that makes it easier, all right? So now we say the area is 1/2 plus 1 is 3/2. So x to the 1/2 plus 2/2 is 3/2. But we're going to multiply top and bottom by the reciprocal. So 2/3. So maybe memorize this one. The integral of x to the 1/2, or the square root of x, is 2/3 x to the 3/2. So this is 2/3, and then that's x to the 3/2, and we're going from a distance of 0 to 4. But remember, it's f of b, the upper bound, subtract f of the lower bound, a. So f of 4 subtract f of 0. Well, when we plug 4 into that function, so I'm going to leave a 2/3 on the outside, and then on the inside it'll be this f of b subtract f of a. All right, so when we substitute a 4 there, well, the denominator is the radical, so the square root of 4 is 2, 2 cubed is 8. When we plug a 0 in there, 0 to a fractional exponent is still 0. So 8 subtract 0 is 8. And now we just have 2/3 times 8, which is 16/3 units squared, since we're talking about area. All right, I'm going to pause this and pause this, and we're going to do one more of these. Okay, we need to find the area enclosed by those two functions. Well, look at what the upper function is. It's the area under the x squared over 2 subtract 1. Subtract the area under this right here, and that's this function. So we want that area right in through there. So when you go to integrate, it's the upper function. So think about this. It's the higher function subtract lower function. At least in examples like this where 1 is above, when it's respect to y, it'll be the right function subtract the left function. All right, so we're going to say area is equal the integral from 0 to 3, and the upper function is, so I'm going to do this. I'm going to put 2 sets of parentheses in there and then do the dx. So in the first set, it's x squared divided by 2, subtract 1. The second set is this linear function, 1/2 x, or x over 2, subtract 4. And then we're going to clean this up before we integrate it. Are there any other x squareds? There is not, so I'm still going to leave this as x squared over 2. And then there is an x, but that's subtract a negative, so that becomes positive x over 2. And then we have -1 subtract -4, so that's -1 plus 4, so that's 3, but because these have 2, I'm going to write 3 as 6 over 2. And then notice they all have this 1/2 in common, so I'm going to bring a 1/2 out here and then finally out there. So I'm going to rewrite it now as 1/2 times the integral of 0 to 3, and now we have x squared plus x plus 6 dx. So now we can start integrating. So area is equal to, so we're going to put the 1/2 on the whole outside of this, and then the vertical line from 0 to 3, and then our equal sign. And I probably made that way too far away, so I'm going to fix that right now. It's probably more about like that. All right. So the integral of x squared, remember we add 1 and then divide by that. So it's x cubed divided by 3. So x cubed divided by 3 is the integral of x squared. The integral of x to the first, you add 1, divide by 2. So that's x squared divided by 2. And then the integral of 6, well, think about it, that's x to the 0. So when you add 1, 0 plus 1 is 1. Well, 6 divided 1 is still 6, so you get 6x. And then, so we know what the integral is, and now we have to apply the upper bound and lower bound to it. So I'm going to make that a little bit thinner. So we have a 1/2 on the outside, and this is uppercase f of b subtract f of a. All right, so I'm going to plug 3 into all of this. Well, 3 cubed is 27. 27 divided 3 is 9. 3 squared is 9. 9 divided 2 is 9/2. And then 6 times 3 is 18. But if we want each of these to have that denominator, 9 would be the same as 18/2, and this would 18 would be the same thing as 36/2. So I'm going to leave it like that, and then we're going to put 0 in. Well, when we put 0 in, they all will just zero out, because 0 cubed, 0 squared, 6 times 0 are all 0. So now all we have to do is add all of these things together. So 18 plus 9, so 18 plus 9 is 27 plus 36. So we've got 63/2 on the inside times 1/2. So that is, looks like, is 63/4. Oops, 63/4. And then you can go ahead and also put the approximation value if you want to. But this would be the exact value, and then the approximation and tack on units squared. All right, that is it for this one.